rockets explode. Sometimes on purpose. That sounds wrong, but it is exactly how spaceflight protects people on the ground. Today, you will hear why those explosions can be the safest outcome, how invisible red lines in the sky decide a rocket's fate, and what really happens when debris returns to Earth. Stay with me, because in a few minutes we will raise an engine from the bottom of the ocean and read the number that links it to the first landing on the moon. On the launch pad, failure is violent and obvious. Fire, smoke, shrapnel, a tower of flame that bends metal into scrap. Once a rocket clears the pad, the rules become even stricter. Launch ranges paint boundaries you cannot see. Imagine a corridor through the air and over the ocean. A safe path that keeps the vehicle away from towns and ships. If the rocket strays outside that corridor, the flight must end. The term is flight termination. It sounds cold because it has to be cold. Break the vehicle apart now so the fragments fall where no one lives. Years ago there was a person with a switch. A range safety officer watched the track and held the authority to send the command. That era ended for a reason. Modern launch vehicles carry their own judge. GPS and inertial sensors know where the rocket is and where it is headed. If the guidance drifts toward a red line, the logic is simple. Stay inside the corridor and continue. Cross the boundary and cut the vehicle into smaller pieces over water or empty land. No hesitation. No radio delay. When a machine moves faster than a rifle bullet, seconds matter. Automation wins? Myth to retire. Someone in a bunker does not hover over a big red button anymore. Reality. The rocket decides, because automation removes delay and removes doubt. That is how you protect the people below. This is not drama for its own sake. It is risk management. A controlled breakup reduces kinetic energy and spreads debris in a footprint you planned days before liftoff. Engineers do not roll dice with the public. They design so that the worst case happens in the least harmful way. It looks terrifying, but it is a success when the area under the path stays safe. Now think about the parts that separate by design. Boosters and stages peel away and begin their fall. The teams on the ground have already outlined splashdown zones. Not exact pins, but honest footprints where the ocean is asked to catch. Sometimes ships wait nearby to recover hardware. Sometimes the sea keeps the remains and time turns them into reefs. There is one story that never gets old. After Apollo 11, pieces of the mighty Saturn V dropped into the Atlantic and vanished into darkness. For decades those engines rested in cold water. Fish threaded through the frames. Sand drifted across edges. Then a private expedition decided to look. Sonar painted the bottom. Remote vehicles prowled the wrecks. The team lifted metal through the green and scanned for proof. They needed a serial number. A mark that could tie this engine to that mission. When the right sequence of stamped digits came into view, history snapped into focus. This was muscle from Apollo 11. The hardware that helped push 3 humans toward the moon had slept under miles of water. Now it was back in daylight. Most people planned to watch a movie on the weekend. Some people planned to race engines from the deep. If this already changed how you see launch failures, say so with a like so more people hear the facts instead of the myths. In a moment we will look at the red cloud you never want to see and why some launch corridors gamble with statistics. So we know how safe corridors work and we know how planned debris falls behave. What about the clips that show hardware coming down near villages? You may have seen a flash, a thud, and a red cloud rising while families stand in doorways and fields. That cloud is not only smoke. Some upper stages use hypergolic propellants. Hypergolic means the fuel and oxidizer ignite the instant they touch. No spark needed. This simplicity is good for engines and bad for people who breathe the plume. Name the chemicals once and remember them. Monomethylhydrazine is a common fuel. Nitrogen tetroxide is a common oxidizer. When tanks rupture, nitrogen dioxide can paint the sky a rusty red. You do not want that near lungs, crops, or water. The immediate danger is the blast. The secondary danger is the plume. Even when quantities are not enough to poison a region, you still do not want that cloud drifting through a neighborhood. Safety should not rely on luck. Why does debris ever fall near people? Geography matters. Policy matters. Some launch sites sit inland and send vehicles downrange over sparsely populated areas. Planners lean on statistics. Most days, nothing hits a roof. Most days is not a plan. This is why strict range rules exist. This is why automated termination exists. You trade a single controlled failure for the protection of everyone below. Spaceflight is not only machines. It is people and culture. Agencies ask astronauts and engineers to visit classrooms and gyms because the mission includes the next generation. Someone stands in front of a room and explains that the future is not magic. It is choices, rules, and teamwork. Shake hands. Answer questions. Leave one student thinking that maybe this path is open to them. There is a week each year in Israel dedicated to space, time to honor the crew of Space Shuttle Columbia and Ilan Ramon, the first Israeli astronaut. There are STEM events. There is a technical conference. There is a memorial that turns grief into purpose. Remembering is not about staring into the past. It is about carrying lessons forward so another crew launches wiser and safer. Ask astronauts where their path began, and many will point to a picture. The famous photo of Earth rising over the lunar horizon hung over a desk. A blue marble in black space. That image becomes a compass. On the days when calculus hurts and labs run long, you look up and remember why it matters. Inspiration needs determination to become real, but a picture on a wall can be a promise you make to your future self. There is another truth that opens doors. You do not have to be a test pilot to go to space. The course needs scientists and engineers. It needs people who can design experiments, repair hardware with thick gloves, and make steady decisions when a checklist is not enough. If you can solve hard problems with a team, the path is wider than you think. Careers bend in interesting ways. Some people move from government programs to industry. Mission control is still mission control, whether the patch says agency or company. Cargo vehicles need operators. Crew vehicles need procedures. Someone has to define how to strap in, how to talk to the ground, how to work touchscreens with pressurized gloves. Someone has to help design suits, seats, displays, and the small human touches that make a spacecraft more than a machine. You hear a lot about public versus private as if spaceflight were a tug of war. The reality is a partnership. The agency sets high-level requirements. Move crews safely to orbit and bring them home. Meet thousands of standards for life support and reliability. Companies design and build to those standards. Both sides verify. This model is not new. During the Moon program, private contractors built major pieces while the agencies set goals and signed off. The slider has shifted toward more responsibility on the company side, but the framework is the same. Set the target. Prove you meet it. Fly when both sides agree. Now circle back to the exploding rocket that fills your social feed. Ask better questions. Was the failure random or was it commanded by the safety system? Did the debris land where planners expected? Did the exclusion zone stay empty? If the answers are that the destruct was intentional, the splash zone was clear, and no one was hurt, then the fireball is not a disaster. It is a confirmation that the rules worked. I know it still feels intense. Windows rattle. Chest cavities hum. Cameras shake. That violence is not for show. It is a last defense on behalf of people who never asked to be part of a launch. Protect the public first. Hardware second. Pride last. You can build another vehicle. You cannot undo a tragedy. Here is the payoff I promised at the start. Imagine standing on the deck of a ship as a crane brings an engine out of the water. Barnacles cling to metal. Leanest drip. On the casing, a sequence of stamped numbers comes into view. Technicians nod. Records match. This piece of steel helped push humans toward the moon. It became a fish habitat, then an artifact, then a story you can tell your kids. Space is not only new, it is also found again, rescued from the seafloor, cleaned and placed under a light so people remember what was risked and what was learned. So what should you take from all this? Red lines keep rockets from becoming missiles. Automation removes hesitation. Plant footprints keep the ocean busy and communities safe. When debris comes down near homes, the problem is not bad luck. It is a planning choice. Outreach and memorials turn grief and awe into better decisions tomorrow. A poster can launch a life. A partnership can launch a mission. Tell me in the comments whether an automatic destruct is more or less scary than a human on a switch, and why. I will pin sharp answers. If you want the full debris story, watch the next video in this series called What Falls Back Down. It is linked on screen now. Then subscribe for more straight talk that cuts through the fireball and shows how space really works. Until then, keep looking up and keep asking why the rules are written the way they are. Every boundary in the sky, every zone on a chart, and every decision in a control room is a promise to the people below. That promise is the reason we get to launch again tomorrow.